So this iron is not a god, and in my last video, I was able to prove it to you that everything that is happening to this iron is due to physics. But one thing I didn't see coming is so many people disagreeing with my calculations. A lot of people in the comment sections are so blinded by what they believe that they don't want to look past whatever they believe. So many people in the comment section were saying, if you say that this is physics, now use your physics to explain to us why this iron moved from one place to another. A lot of things has been attributed to this iron, therefore making a lot of people believe that this iron is a kind of god. Some of the things that are attributed to this iron is the fact that they believe that nobody can lift the iron, although in my last video, I was able to disprove that claim. Other things that are attributed to this iron is that this iron moved by itself. Even though nobody can lift it, the iron moved by itself. Therefore, if you find this iron in a place today, if you come back tomorrow, you won't find it in the same spot. Another thing that is also attributed to this iron is that no matter the kind of pressure you put on this iron, it doesn't melt. Now, a lot of people ask me to use physics to calculate why this iron moved by itself, and in this video, we are going to look into the reason why this iron is allegedly moving by itself. In my next video, we are going to use science to explain what could be the reason why this iron doesn't melt. But for now, let's explain why this iron is allegedly moving by itself. The subject that we are going to use to solve this problem is motion. And under motion, we are going to need two other subjects under motion, and these subjects are Newton's law of motion and displacement. What is Newton's law of motion? Newton's law of motion are three, but we are only going to need the first law because the first law of motion is going to explain to us what could possibly be moving this iron from one place to another. So what is the first law of motion? According to Newton's law of motion, the first law states that a body at rest will continue to stay at rest unless it is acted upon by a force. And this law also states that a body in motion will continue to be in motion unless it is acted upon by a force. Let me explain this in a real life situation. Let's say I have a smartphone and I drop this smartphone at a particular point on the table. This smartphone is a body that is at rest on that table. Now you should know that force is a pull or push action. As this smartphone is at rest on that particular place, for you to move this smartphone from that place, you must exert force on that smartphone. This is exactly the explanation of the first law of motion. Also note that this first law says that a body in motion will continue to be in motion unless it is acted upon by a force. What does that mean? Motion is something that is moving. A body that is in motion will continue to be in motion unless it is acted upon by a force. Let me explain what this means in a real life situation. Let's assume that there is no air, there is no friction, and you went to a flat surface and rolled a ball. What do you think will happen to this ball? Well, if you don't know what will happen to it, because there is no air, there is no friction, there is nothing stopping this ball, it will continue to roll and it will never stop. The only reason why this ball is going to stop is unless a force is acted upon on this ball. That is the only time this ball is going to stop. Let's say as that ball is rolling, you go in there and put your leg is going to exert force on the ball and the ball is going to come to rest. Let's say as the ball is rolling and you push breeze to it, the breeze is going to exert force on the ball and the ball will eventually come to rest. So this explains Newton's first law of motion. Now that you understand Newton's first law of motion, let's establish a fact. If you said you understand the Newton's first law of motion, now you will agree with me that when this iron is sitting on rest at any particular place, a force must be exerted on this iron for it to move from one place to another. If you agree with me, then we have established the first fact, which states that for this iron to move, a force must be exerted on the iron. Since we have established that fact, now let's look at what is displacement. Displacement can be said to be the calculation of final destination relative to its initial destination. What does that mean? Let's say a boy is standing at a particular place and he decided to move eastward. Now, this boy started moving eastward and he traveled 5 kilometers east. But after he got to the 5 kilometers towards the east, he decided to turn back and move 5 kilometers westward. Now, if we are to calculate the distance that this boy traveled, it is 5 kilometers plus 5 kilometers, which is 10 kilometers. But if we are to calculate his displacement, remember, he moved 5 kilometers east and decided to turn around and move 5 kilometers west. His displacement is 0. It means after traveling 10 kilometers, he still came back to the place he left. That means his displacement is 0. Now that you understand what is Newton's first law of motion and displacement, let's look at how these two subjects could help us understand what could possibly be moving this iron from one place to another. In the first part, we established a fact. Do you remember the fact? If you don't, I will help you. We established the fact that if this iron is sitting at rest, a force must be applied to this iron for it to move from one place to another. And if you agree with that fact, then let's look at what type of force can actually move this iron when it is sitting at rest. And there is only two forces that could do this. The first one is called applied force, and the second one is called tension force. But what is applied force? Applied force is basically a force that is applied by either human or substance or machine. Let's say if this iron is sitting at a place and I decided to move that iron by lifting it and dropping it in another place, it is applied force. Let's say this iron is sitting at a particular place and I decided to hit it with a car, it is applied force. Now, what is tension force? Tension force is almost the same thing as applied force, but now something must be attached to the iron. Let's say this iron is sitting at rest at a particular place and I decided to use chain to tie it round and draw it with the chain. That is called tension force. So these two are the only force that are capable of moving this iron from one place to another. If you agree with me on that, then we have established a second fact. Now that we have two forces that could actually move this iron when it is at rest, let's look at which one is more possible to be acting on this iron. Applied force or tension force, which one is most likely moving this iron when nobody is looking? Let's dive into it. Now, the answer to this question is actually very simple if you are open-minded. But because so many people are not, we are going to explain it. First of all, one thing you should understand is that this iron is in a public place. It is inside a forest, and it even makes it more public because if anybody is actually there lifting this iron, you wouldn't be able to see them unless you are with them. Now, since this iron is in a public place and it have a very interesting story, this iron attracts a lot of people. A lot of people visit here often, and when they visit, they always try to lift the iron, which they end up lifting when they bend the iron. And when they bend this iron, they actually lift it, and sometimes when they drop it, they don't drop it in the same place where they lifted it from. Because so many people come to this iron and lift it and move it, that is why if you see it in this place today, you come tomorrow, you will see it in the next place. And that's exactly how this iron is moving.